Hello, so this is going to be our first program in which we're going to build a modified version of the Hello World program. We're going to print the first letter of Hello World, i.e. the H, to the screen. Now, we're very lucky that we have many high-level languages which come with many helpful functions such as print, which can print stuff to the console. But the problem we have is that we don't have access to any of these. So we have to make our own functions or talk directly to the hardware through addresses. But we'll get to that. The first thing I've done is I've made a new folder called OS on my system, and I've opened it up in Visual Studio Code. So what I'm going to do is, to keep organized, I'm going to make a new folder. I'm going to call that boot. This will have the code for the bootloader. I'm going to make a new file called boot.assembly, which will contain the code for the bootloader. The first thing you need to do is you need to specify a origin for your code, and the way you do that is you use the org command and you specify a hexadecimal right here, which is 0 from in this case. The next thing you need to do is you need to specify the bit system, and we're going to be using 16 bits. Then you specify a section which I call code. Then I'm going to use a label called main. The way labels work is that labels refer to the address of the next command after them. So whatever command I have right here, whenever I type in main, it will refer to the address of this command. Labels are very useful in loops in which we can jump to the command after them very easily. So the command we're going to be using is the first command we have is going to move a value to the ES register. And the reason is that in the next lesson, we're going to be using a loop, and this will be really useful for a loop to have a base address. So what we're going to do is I'm going to move a value to ES, and normally you'll be able to do something like this, which will move a value to the ES register, but this will not work, and the reason is that the ES register needs an intermediary register. So the actual command is that we first of all need to move a value to the AX register and to the EAX register, and it's going to be called 0xb800. So this moves 0xb800 to the EAX register. Then I'm going to move the value of the EAX register to the ES register. So now ES register has the value 0xb800 like we wanted. Now we're going to move the value that we want to print to the screen. And if you remember, 0xb800 is the magic number for the first character on the screen for the computer. So 0xb800 refers to the first character. We're going to move 2 bytes. The first one is going to be the character we want to print, and the second byte is going to be the color of the background and the color of the text. So what I'm going to do is I'm going to move a byte, and I'm going to use the ES register as the base address, and I'm going to offset it by 0x00, and I'm going to move a H. Just to explain how this is working, this bit here is working. We take the value of the EX register, which is 0xb800, and then we add in the value after the colon, which is 0x00, which is equal to 0xb800. So it does not do a lot for this command, but this will be really helpful in a loop. So the next command is we're going to move a byte, again using the ES register as the base, and we're going to say 0x01, which is the next byte along, and we're going to move the value 0x30 in there. So this will be moving the value 0x30 to the address 0xb801. Now this value right here I suggest you play with, because this refers to the background color and the text color. So the first digit, the 3, refers to the background color, which is blue, and the 0 refers to the text color, which is black at the moment. So I suggest you play with this, play around and find some values that you like. I'm going to go with this. The next command is going to be an infinite loop, so that once the program runs this, it doesn't try to run the next commands after it. And what we're going to say is I'm going to say jump and then a dollar sign, which basically means jump to this command and keep jumping infinitely. Now the program is the main body of the program is done, but this will not run. The reason is that it's not the right size. We need to make this 512 bytes, and the way we do that is we use a command called times. We say 510 and we say dollar minus dollar dollar, and then we give it what we want to pad with, which is 0 at the moment. So what this command does is it pads the file with zeros, making it the right size. So yeah, but this will still not run. The reason why we said 510 instead of 512 is that we need 2 more bytes at the end of the file for something really special, because the computer needs to have a way to distinguish between executable code and just data. And the way it differentiates is that if you have the bytes in hexadecimal 55 and AA at the end of the file, that tells the computer that this is an executable chunk of code. So we're going to do that. So we're going to say db0x55 and we're going to say db0xaa. So now we are done with the code. So what we're going to do is, in order to compile this and make our lives easy, we're going to make a makefile. And the makefile will by default make the bootloader, and the bootloader will have the following command. So we're going to use the NASM assembler, and we're going to give it the path to the binary code, and we're going to specify an output file which is going to be in the boot folder, and I'm going to call it boot.image. Then we're going to have a clear command which will delete all the files that this makefile generates, just so that we have a clean directory structure again, just with just the code. And I'm going to remove the boot and boot.image file that we just created. Then the interesting command is the run command. What we're going to say is we're going to be using something called Camu, which is an emulator to run the code. And the way the command goes something like this. So you say Camu system x86 underscore 64.exe, and then you give it a load path, and this will save us from some errors. So we need to specify the path to where Camu is stored on the system. It is stored in program files and a folder called Camu for me. It will be different, it might be different on your computer, so please change this to where Camu is located on your computers. Then we're going to specify the mode we're going to be running. So we're going to be running a 64-bit mode, and we're going to be loading the code as a floppy disk, so hence FDA, and we're going to give the path to the code that we're going to run, and this is it. So what I'm going to do is I'm going to open a MingW terminal, and the way you do that is you say run terminal, and that opens it up. I'm going to cd into this folder with my OS folder, and the best way to do that is to click your makefile and copy the path, and then go over here, type in cd and right click, and then get rid of the makefile. So this will cd you into the directory that we want. Now I'm going to run the run make by using the command make, and as you can see, this has built the image file for me. If you try to open the image file, you'll see that it's like a random like a normal binary data with random text. And hopefully now that I type in make run, this will actually run Camu and print the hello, the hatch of hello world onto the screen. And as you can see, we have a hatch right here with on a blue background with black text, and you can play with this. So for example, if I change the background color, I can change it to 4, and this will, if I run again my commands again, as you can see, now we have black text on red background. And you can even change the color of the text by changing the second digit, so this 0 here to something else. But I'll leave you guys to play with this, and I'll change this back to 3, and because I really like the blue background and black text. Now one issue that we'll sort in the next lesson is that if I was to make this again and run this, you'll have a look that we have text that was rendered previously, and we're not getting rid of it, so we're not clearing it. So this is going to be the next lesson in which we get rid of all of this. So I'll see you guys in the next lesson. Bye.